Good afternoon, everyone. My name is Yaroslav Borys, and today I will present the results of the research on the topic Intelligent Systems for Recognizing Artistic Styles, a Deep Learning Approach. So, what's the goal of the research? The goal is to develop a system for classifying image styles and further study obtained models. But what is the style itself? It's a set of colors, compositional elements, drawing techniques, textures, and other factors. Traditionally, defining styles was the prerogative of an art historians. It's a long and complex process that requires great knowledge. So, why do we need such classification system at all? The thing is that in recent years, the number of both artists and digital art has increased dramatically. This includes paintings created in programs such as Photoshop, Krita, and others, images created with various filters, then uploaded to different social platforms, and of course, the images generated by artificial intelligence. And in the coming years, this number is only expected to grow, as shown on the plot on the slide. And therefore, we need a system that can quickly and accurately classify this entire generated volume of images. There are, of course, systems that can already classify by author and genre, but there are not enough such systems that classify by style. Well, where can the classification by style be applied? In many areas, including art and cultural studies. It's mainly for automation and for finding some hidden trends of different areas, of different styles, and their relationship. Then museums and galleries mainly for interactive exhibitions and general improvement of the visitor experience. Digital digital archives, it's automatic tagging and categorizations, education, developing new tools for art students, thus helping more and more people to learn more about styles, because the situation is that when we are talking about some painting, famous or not, what many people know is the name of the painting, the author who created it, and that's it. Style is sometimes mentioned but quickly forgotten. And of course, commercial applications, ranging from creation of different filters to using the results of classification in recommendation system on different platforms. There are already existing research on said topic, but most are purely theoretical. For example, the first article, it considers a new feature extracting approach, but the thing is that it's just that, theoretical. Yes, it works on some local environment, but it's not implemented as a ready solution. Uh, if we look at the fifth research, for example, it's a bit better situation. It has 95% accuracy, but the problem is that it classifies only two styles, namely realism and naturalism. And if we want to use it as a ready product for everyone, two styles are a bit low. Of course, there are already made solutions. At the time of the research, I found three of them, and from the left to the right, they are Art Style Identifier AI, Art Style Explorer, and Nickel. The thing is that the first is just an extension for ChatGPT, meaning that if we want to use it every day, it has a limit of usage. Now, it's great. It correctly determines the styles, it determines compositional elements, it presents it to you in a great format. But yet again, if we want to use it constantly, it's a bad option if we want to use it free. The next, Art Style Explorer, is also a great tool. It's a combination of different models. But the thing is, it's not purely determining the style of an image. It's a tool that generates new images based on the style and compositional elements of the current. And Nickel is not a system for style classification, it's a system for genre classification. So while it can be used to help determine compositional elements, it's not really a solution. So the study used WikiArt set containing over 1,000 high-quality images, divided into 27 styles, as shown on the left picture. For the training itself, 5 styles were considered, namely abstract expressionism, colorfill painting, mannerism late Renaissance, naive art primitivism, and post-impressionism. For each style, 1,000 images were taken. And of course, then they were further split into training and validation set, namely 800 for training and 200 for validation. Uh, the development of the developed CNN architecture is actually quite simple and consists of only 4 convolutional blocks, as shown on the right picture. The first convolutional layer has 16 filters, followed then by 64 filters, 128, and yet again 64. All filters are the size of 3 by 3, which guarantees balanced feature extraction. Now, for better accuracy, then further down the line, data augmentation was also implied, namely random rotation, random reflection, and random scaling, as shown in the overall overview of the processes, how it was trained and how it was created. So, the training itself. In the first iteration, which is shown on the top, the best accuracy we were able to achieve was about 0.6 for both training and validation set. Well, validation set is a bit lower, but the thing is that on the 12th epoch, we have a quite significant difference between validation loss and training loss, which implies that we encountered overfitting. As was mentioned earlier when data augmentation was used, also we applied regularization with a parameter value of 0.01 to reduce overfitting. And yes, we succeeded, as shown in the pictures below. The new accuracy on training set reached 0.7, and validation set accuracy reached 0.63. While there is still some overfitting left, it's way better results. Now, this slide presents the confusion metrics to further analyze how the styles are learned and how the model is able to determine them. So, as you can see, the model learned 3 classes best. On the picture, they are labeled 1, 2, and 4. In reality, they are colorfill painting, mannerism late Renaissance, and post-impressionism. Now, about other styles, abstract expressionism, which is labeled as 0 here, is often confused with colorfill painting. Well, and it's kind of, I'd say, okay result. No, well, it's not okay result, but it's a predictable result because these styles are both the subset of a general abstract style. Now, surprisingly, the model completely failed to learn the naive art primitivism style, which is labeled as 3. So, yet again, the accuracy for the training set is 0.7 and validation 0.63. As we want it to be not a theoretical approach but a practical one, interface was a mandatory thing. So a simple interface was also implemented, and it consists of 3 main sections, namely the section for image loading, the section for model selection, because further down the line new models will be tested and created, and also the section with the results. Of course, the interface right now is quite simple, but it will be further refined down the line. In conclusion, we obtained a model with 0.63 accuracy, which is able to distinguish between file styles. While the solution represents a functional approach, it's not perfect and can further be optimized. Now, how to optimize? The first is to just change the CNN architecture because, as was mentioned earlier, we used 3 by 3 filters. They are optimized, but they may fail to extract some local features from the image, or they may fail to extract some complex nonlinear relationships between different features on global scale. So the idea is to add a few 1 by 1 filters and 5 by 5 filters to locate those localized and more complex features. The next approach is the use of ensemble, because right now the model, as can be seen, struggles with file styles. So the idea is that reduce the complexity of the model a bit, so it can learn 2 styles, perfect, well, better than 5. And then the idea is that each model learns a pair of styles, which looks like its own style, and just the other rest of them. Then we can combine those obtained results from every single model to determine the style of an image with, we hope, better accuracy. The last option is to use transfer learning on pre-trained models like VGG 16, 19, exception, and others. Because as shown in studies, transfer learning so far gives better results than trying to come up with some feature extraction approach or just using custom CNN architecture. So that's all, and thanks for your attention. Goodbye.